Good day, everybody. My name is Daniel. Today I'll be taking you through, I'll be taking you through a tutorial where I basically demonstrate the use of vectors in C++. So what is a vector to begin with? A vector is an array-like container, like I've stated here. It's an array-like container where it's a linear data structure, and it kind of simply looks like an array. However, a vector container, takes the weight off of you. As you know, if you're using arrays, you would need to use pointers, and you would also need to keep track of what the size is, depending on what type of manipulations you want to do. So with a vector, you don't really need to do any of that stuff. It's an easy way to work with array-like data, or data that you want to store in an array-like object. So without further ado, we're going to get started, but I just want to go through some of these operations that we're going to go through. So we're going to be doing standard traversal. We're going to be traversing through the vector using iterators, and I'll tell you why why it's advisable that you use iterators. We're going to be going through some of these methods over here: push back, pop back, insert, capacity, and size. And I'm just going to take you through this page, C++ reference page, where you can go look at really the definition of the vector container, and you can go through all these methods over here, depending if you want to do some more complex work. So, but my tutorial will be just to give you a heads up, or simple tutorial, get your foot inside the mud when it gets to working with the vector class. So let's get started. So now we have a vector here. I've already declared and initialized the vector. I've given it values in here, so 3 elements inside. So what we're going to do first is that we're going to write a function that's going to iterate through the vector. We're going to write another function that's going to iterate through the vector, and it's going to be using iterators, right? In both functions, we're going to be outputting the vector, so we're going to be printing out the elements inside of the vector. So without further ado, let's get started. So the function will return a void because I'm not returning anything, and then we're going to name it iterate vector, right? So it's going to take in the actual vector. So how you do that is vector. I'm gonna pass in the integer, the type, and then we're gonna say it's my vector, right? So I'm gonna reference it so that whenever I use this function, we don't have to copy this vector over and over and over inside of this function. You don't have to do this. However, it's advisable that you do, depending on what exactly it is that you're doing. But for the sake of this tutorial, I'm going to use this ampersand sign before the name of the variable of my vector. So now I'm just going to loop through the vector, and then I'm going to print out the elements inside the vector. So for auto a or elms, since they're elements, and then I'm going to call the name of the vector my vector. This is a standard way of iterating through a vector or iterating through a container. And then we're going to print out the elements inside the vector. So std cout elms std end line is so that we can go to the next line after printing each and every single element. We're going to call the function iterate vector, and I'm going to call which vector I want to iterate, my vector. There we go. So now let's try and print this. Excuse that. So I'm gonna compile, and I'm gonna run the file. You may be using an IDE, so you would just run build and run, or just run. In my case, I'm gonna say g++ test.cpp. It compiles, and then I'm gonna run it a.out. So there we go. So we've just basically printed 3 elements inside of the we've printed out 3 elements inside of the vector container. So now we're gonna do the same thing. Instead, we're gonna say iterate using iterators. So I'm gonna paste that here, and we're gonna iterate vector with iterators. So I'm just gonna remove this code over here. So here's our bare bones. So the same thing, same arguments, and now we're gonna actually declare the iterator. If you guys want more information about how to use iterators, you can check out my previous video where I go into detail about using iterators and the reasoning for it exactly. So std vector, it's a type of int, iterator, we're going to name it it. But instead of leaving it like this, I actually want to give it or initialize it. So I could just say it equals to myVector.begin, which will point to the beginning of the myVector container. So it'll point to the first element, and then I could now write my loop, right? So I want to loop and actually print out the value, or what the value that the iterator is pointing to. So how we go about that is a simple for loop. So I'm just gonna say for it, which is my iterator, which we already declared what it should be equals to, which is the vector.begin, and then I'm gonna say it as long as it is not yet equals to the end of the vector. So I would say my vector.end. I would now increment the iterator, so it, so because it's a for loop. And then now I want to print out the iterator, or the value that the iterator is pointing to. So how you go about that would be std cout. I would dereference the iterator. The reason I'm dereferencing the iterator using an asterisk is because if I just print out it, what's going to happen is that it's going to print out the address, the memory address of iterator. So we don't want the memory address, we want the actual value. So you dereference it like that. And then with that being said, now you can actually use this. So I'm just gonna do this std cout. I'm gonna say end line, std end line, and then I'm gonna call the function iterate vector with iterators right here. Pass in my vector like that. So what I'm doing here really is okay, I think I have an issue here. I don't want to be concerned I don't want to be too worried about problems over here. So what I'm doing over here, right, I'm calling the iterator, the initial one, and then now I'm calling the second one, which I'm using a function where I'm using iterators. So now let's just see what the output is. I'm going to compile my code, and then I'm going to call. So as you can see, the first function runs 10, 20, 30, and then the second function runs 10, 20, 30. As you can see, they output exactly the same thing. So if you want more information about iterators, watch my previous video about iterators. Now, since we've done these two operations, let's move on to testing these methods over here. So I'm just going to comment out these two functions over here, and then now we want to write a function that's going to manipulate the vector that we have over here, right? So let's start off by pushing items inside of the container and then printing it out, and then also removing items from the back of the vector and then printing it out as well. So we're going to use these methods, push back and pop back. So let's write a method that says it's going to be a void, and then we're going to say manipulate vector. So same declaration. So my vector is passed in there, and then we're going to add elements inside of the vector. So I just want to touch on something real quick. We could have used a const here and said const, because if you know what const is, it just basically means that we don't have to const basically ensures that we don't manipulate the vector. Since this function just wants to print, or we just want to print elements from this vector, we can use a const variable here to ensure that we don't actually manipulate anything. And if we were to manipulate this vector, or add elements, or do any sort of operation such as pushback or whatever, it would throw a compile error. It wouldn't allow us to do it. And so in this case, we wouldn't want to use a const, right? Because we are actually going to manipulate the vector. So with that being said, now let's push some elements to the back of the vector. How we go about that is that we're going to call the name my vector dot push back, and then let's just push back 100, and then let's maybe push back 2 items, not just one, and then this one will be 200. Oops, there we go. So now let's try and print out this vector and see what the output is. So to do that, we're going to call this function called iterate vector with iterators. We could have also used this one, but either way. And then we're going to pass in my vector, since it takes in a vector. And then let's compile, and then let's run. Okay, let me just do this. Can't see clearly. Apparently nothing was done. Oh, the reason nothing is happening is because we didn't call this manipulate vector. So let's call that function manipulate vector, and then let's pass in my actual vector like that, and then let's run that again. Compile it first, and then let's run it, and then there we go, 10, 20, 30, and then those 2 elements have been added to the end of the vector. So now what we want to do is that we want to pop back and see what actually happens. So let's just add a pop back method, or method to the vector here. So we would have pushed 100, pushed 200, and then we pop the last element in the vector. So actually the result should be that it's popping out the last element inside of the vector. So we'll say my vector dot pop back, and then we don't give it any arguments. It doesn't take any arguments because it knows exactly which item to pop. So now let's run that, compile it first, and then run it. And then as you can see, it's 10, 20, 30, and on what happened here is that 100 was inserted, 200 was inserted, but then the pop method ran and it removed the last element before we actually started to print out the elements inside of the vector. So that's what happened. So now I wanna do another operation called insert, right? Let me just create another function, and we're gonna use the method called insert. So I'm just gonna copy this and paste it over here, and then I'm gonna say insert in vector. We're gonna call it insert in vector, and then we're gonna remove all these, and then I'm just gonna comment this one out, this function out. And then we're going to insert elements. I'm going to show you how we use the insert function, or the insert method of the vector. So what we would do is that, let me just give you an explain what the actual implementation of the insert method looks like. So it looks something like my vector dot insert, right? And then you pass in the position of where you want to insert your elements, the count, how many times you want to insert that element, and then also the value. So what exactly you want to insert inside the vector. So, but you don't need this count. You could actually just if you just want to insert one value at a specific position, you don't want to insert it multiple times or numerous times, you could just use the insert method like this instead of like this. So let's just stick to the basics. So what position do we want to insert? So if we say 0, then it would insert it at index 0, which would be before the first element, or before the first, before the first element. So it would insert whatever we want to insert here before the 10. However, so to do that, we can just specify position 0. It takes in what we call a const iterator. So a const iterator, that means that we need to pass in an iterator to where we want to insert the value at the position. So we would have to create an iterator, right? std vector int, it's type of int, and then we will say iterator and it, right? And yeah, so that's my iterator. Currently it's not pointing to anything. However, I wanted to point to the first element, right? So I would say equals to, I would initialize it and say my vector dot begin, like that. So now it's pointing to the first element inside of the vector. Now we can pass it right here, it, right? So that would be equals to 0. The index is 0 because it's at the very beginning of the vector. So, and then what value do we want to insert? Let's just insert 700, right? So as you can see, the errors went away and this should work. However, if you wanted to add it to, let's say, position, let's say 2, 0, 1, 2, we would say plus 2. Because that's where we want to insert it. So let's just first work with at the beginning of the iterator, at the beginning of the vector, and then let's print out whatever it is that we want to print out, right? So I mean the vector, let's print out the vector. So we would call this function again, iterate vector with iterators, and then I would say paste this here, call this function and pass in my vector, and let's call this function, which is insert vector, and we're going to pass in my vector, like that. So let's run that, and then let's boom. So we run that, 700 is inserted as the first element inside of the vector, and then we have the rest of the elements that follow the one that we've inserted. So vectors are great because now if you were using arrays, you would basically need to bare bones method of setting the first element inside of the array. You would have to do that manually. So vectors, you just use the insert method and it does that automatically for you, right? Allocates memory, all that sort of thing. So right now, moving on to more important things, I wanna talk to you about the capacity, size, and shrink to fit. These are arguably one of the most important aspects of using vectors. So we're going to create one last method where we're going to test the capacity, size, and shrink to fit method. So I'm going to say void test capacity, and we're going to pass in the same form of declarations, or the same arguments there, because you're still using the same vector throughout. That's why we use this ampersand, like I said. So we're going to test out the capacity, the size, and the shrink to fit. So for me to test this out, I actually want to remove all these elements from the vector so that we start on a clean slate. So let's just start by printing the vector and see what or printing the capacity and the size of the vector before we do any form of manipulation, right? std cout. So how you use this method is that you call the name of the vector, and then you call the method dot capacity or dot size. So it will be my vector dot size, and see, and we'll see what that gives us. So we're gonna actually call this test capacity method or function. So how we go about that is that test capacity, and I'll pass in my vector like that. So let's see what it gives us. So it gives us 0. I just wanna make it readable. Let's see, end line like that. I'm gonna compile this, I'm gonna run it. So there we go, the size is 0. That's the size. Let's also print out the capacity. What am I doing? Let's print out the capacity. It's also 0. So at the beginning of if you just initialize, or not even initialize, if you just declare a vector, the capacity and the size will be 0. So how a vector works, and I'm just going to use skledraw here just to demonstrate. Wow, I don't have an internet connection. And I don't have anything to use. Okay, anyway, it's fine. I'll just explain it. So what actually happens when you use a vector is that it scales itself. So if you insert one element, the size will be 1, right? Because that's the size, how many elements are inside of the vector. The capacity of the vector will be 1. So capacity just basically states that how many elements can the vector take before it needs to resize itself. So the capacity will be 1. But then when you add a second element inside the vector, now the size will become 2, but then the capacity will now double, right? Because it was 1, now it becomes 2, right? It doubled. When you add a third element inside of the vector, it will double again, and the capacity will now become 4, while the size is 3. You have 3 elements, but the capacity is 4. If you add a fourth element, the capacity, it's still within capacity. So you have 4 elements inside of the vector, the capacity is still 4. But then when you add a fifth element, the capacity now doubles itself. So now it will go to 8. So now you have 8 slots of memory available for you to insert your elements. So now you have 5 elements inside, so the size is 5. If you add another element, the size is 6. If you add another element, the size is 7. And then another one, the size is 8. But then the capacity throughout those operations has remained the same. Now when you go above the capacity and you go to 9 elements, so the size now becomes 9, the capacity now will double again. So now it will go from 8 to 16. So that's just how vectors work, and I'll demonstrate that real quick here. We'll just keep adding elements. We'll have a for loop that will keep adding elements, and then we'll just print out the size and the capacity after each element has been inserted. So I'll just add a for loop here. Let's just say till 10, and then we're going to increment. Alright, so we're going to keep adding elements inside of the array, inside of the vector, I meant to say. So how do you add elements? We push back, right? So we're going to say my vector.pushback. We're going to push back just the number, which is just push a 90, whatever, random number, doesn't matter. And then after adding or pushing a number, we're gonna, okay, let me just leave this as that. After pushing in a number, we're gonna print out the size and the capacity. And oh, I can just pass an I here. And then we'll just see. So if we repeat this operation 10 times, we'll see what happens. So let's just print that out. We compile it and then we run it. So okay, I forgot to do something real quick. I want to actually name this. The size is like that. And then let's test out the capacity. The capacity is like that. So there we go. So what actually is happening over here is that when we start, remember the vector there's nothing in the vector, right? There's absolutely nothing in the vector, so the size and capacity is 0. So once we add one element inside of the vector, the size becomes 1, the capacity becomes 1. When we add a second element inside of the vector, the capacity doubles now because the capacity has been exceeded. It will double, so now it goes from 1 to 2. Like here, the capacity is 2, the size is 2. When we add a third element inside of the vector, the size becomes 3, the capacity now is 4, right? Because it doubled, right? And now fourth, it still remains 4. When we exceed the capacity, now we add a fifth element inside of the vector, the capacity now doubles to 8, and so on and so forth. And our last operation, our size is 10, but our capacity is 16. So we added 10. If you remember, we created a loop that iterates 10 times. Here, it iterates 10 times, not iterate, or yeah, just inserts values 10 times, 1 to 10, right? So at the end, as we can see, our capacity is equals to 16. So maybe you don't really want it to expand all the way through each time. Maybe you just want to have, you were never going to exceed 10 elements inside of the vector, right? But this extra allocated memory space, what do you want to do with it? You know, you don't want it. Actually, you don't want to use it. How you could go about that is that you could remove that extra space that you're not using, and for that you could just use this method here, shrink to fit. So let's just say maybe we're done with the loop, and then we wanna shrink to fit, right? We wanna call shrink to fit to remove that excess space that we've allocated but we're not using. We want to get rid of it. So what you would do is that you cut my vector. Since it's a method, you would call shrink to fit, and then just like that. And then let's try and print out these again at the end of the function, and then let's see what it gives us. So we're going to compile it, and then we're going to run it. So it gives us the exact same output, but the difference is when we get to the end, after size is 10 and the capacity is 16, after we call this method shrink to fit, what happens is that now the size is 10 and the capacity now goes all the way back to 10. So now the capacity is equals to the size. So that's basically it with vectors. And there are a whole lot more methods, like I said, you could go through. There's a resize a method that you could also use to do different types of operations. So just yeah, just go and read the C++ reference. I ran out of internet. Oh, here it is. Where is it? The resize. It's also a method that people use. So reserve storage, and then yeah. So there are a whole lot more operations that you could do, or methods that you could call on the vector class. So without further ado, guys, I'm just gonna leave you at that, and stay tuned for more videos. I'll see you guys when I see you guys. Like and subscribe. Cheers.